Learning the language of chemists doesn't stop at reading chemical formulas. We also have to use the names that chemists use to describe different molecules. The naming convention changes based on whether or not metals are involved, so now that we've learned about metals, nonmetals, and bonds, we're ready to learn about chemical nomenclature. Now that we have a baseline of the names for ions, let's go ahead and review these conventions. There are 3 tracks for naming molecules that were learned. The first are binary covalent compounds, or compounds that contain 2 metals, two nonmetals, or nonmetals and metalloids. Examples are H2O and CO2, or water and carbon dioxide. In this situation, the first name is the name of the element in the formula with a prefix denoting the number. The second word is the numerical prefix, the first syllable of the element with "ide" at the end. The elements or names are arranged in the order that are listed in the molecule, which is by increasing group number. So for instance, H2O is dihydrogen monoxide, and CO2 is carbon dioxide. Note, you only use the MON dash, or the single one atom prefix, if the second element in the sequence has a 1. The 1 on the first element, if applicable, is implied. Silly implied ones! The numerical prefixes are listed in this sheet. Why don't you pause and practice for CF4 and P4S10? So CF4 would be carbon tetrafluoride. Remember the implied 1 for the first letter. While P4S10 would be tetraphosphorus decasulfide. The next track, or ionic compounds, or binary compounds between group 1 or 2 metals and group 15 to 17 nonmetals or polyatomic ions. Some examples include NaFKCl. In this case, no numerical prefixes are used. You literally state the name of the cation, then the name of the anion, using the conventions that we used in the previous video. For instance, NaF would be sodium fluoride. Let's pause and practice for CaCl2 and BaCO3. CaCl2 would be calcium chloride, while NaBr is sodium bromide, and BaCO3 is barium carbonate. Aha! You see that polyatomic ion in there? Yep. Now you may notice that we don't use any numerical prefixes we haven't used any numerical prefixes in these compounds because the identity of the metal, because we know the charge, tells us how many of the non-metal will be present. Finally, we have our third category. These are binary compounds between transition metals and nonmetals. Although these are technically not true ionic compounds, they have coordinate covalent bonds with some ionic bond character. We name them like ionic compounds, but with one key difference. Do you remember how we can't predict the charge of the transition metal cation? Well, when naming a compound, we have to tell our reader the name of the charge in the metal. For instance, CuO is copper 2 oxide, while FeCl2 is iron 2 chloride. The only exceptions are silver plus, cadmium 2 plus, and zinc 2 plus, because these transition metals always form the same charge. Let's pause here and practice. So AgCl would be plainly silver chloride because silver is always plus 1. Fe2SO4 is iron 2 sulfate. How do we know the iron is not Fe2 or Fe? How do we know this iron is not Fe3 or some other Fe? Well, we can use the known charge of the anion to figure it out. We know from our polyatomic ion table that sulfate has a charge of -2. If we have one sulfate and the overall charge of the molecule is neutral, there's no charges there, then the Fe must have a charge of +2 to balance out the charge of the sulfate. That leaves us with calcium bromide. That was actually a bit of a distractor there. We don't have to write out the charge of calcium because we know it's +2 because it's a group 2 metal. But we simply write out calcium bromide. Now to finish it off, there's a lot here. So let's draw out a decision tree for writing out chemical nomenclature. The first question is there a metal? If no, then you use the binary covalent nomenclature. If yes, then we have a couple more questions to ask. Is the metal group 1 or 2? If yes, then use the nomenclature for ionic compounds. If the answer is no, the next question is the metal silver, cadmium, or zinc? If yes, then use the ionic compound nomenclature. No number or oxidation state or charge notation is needed. If the answer is no, then you have to use the protocol for compounds containing transition metal nomenclature, also known as ionic bond nomenclature, but putting the charge of the metal in Roman numerals.